Hey, topping in life's math and history, and we are going to take a look at graphing rational functions. So in the past few videos, we've been learning a lot about exponentials. We've also been learning about that, hey look, there's a horizontal asymptote, and there is the function that allows it, and there's the thing or the equation that allows it to go up and down and try to reach that line, but it will never, ever, ever do. But sometimes those exponential equations might exponentially grow into more chaos. Something that looks like this. And you might be thinking, wait, huh? How am I supposed to graph and calculate all this? And is all the equations going to be like really, really big to the point where it's like very complicated? Well, what we're going to do is make that complex equation into a simple how to do it. So what kind of function is this? Yeah, this is called a rational functions. Rational functions happen when they are usually one piece or branch. The graph is continuous, but not everywhere. Wherever the function is discontinuous. The graph will be an interruption when there's some kind of discontinuity. So here's some continuous, here's a continuous, and here's a continuous, but not in these areas. Over here, these two are continuous, but these two are interruptions. Interruptions causes two more things. It will cause a vertical asymptote and a hole. But what is a vertical asymptote and what is a hole? So what we're going to do is learn about what a vertical asymptote is and what a hole is. So there are things we are going to take a look at. So there's the x-intercepts, y-intercepts, and vertical asymptotes. I do think you know what x-intercepts and y-intercepts are, where they strike the x and the y-axis, back from Algebra 1. But when we talk about these, the definitions here are kind of little how-to-do instructions on how to solve the problem that we're going to show. So to find an x-intercept, you'll find it by using the zeros of a numerator that don't cancel out. Don't cancel out? What are we talking about? And y-intercepts. Plug in 0 for x, the numerator and the denominator. Okay, but now the vertical asymptote is non-reversible. Zeros of the denominator that don't cancel. But why are we talking about cancel this, cancel that, don't cancel this, don't cancel that? Well, here's where the holes come in. So holes appear when the denominator becomes 0. This is undefined and broken. So no matter what you try to do, if there's ever a time you ever divide it by 0 or cancel something out, then it's going to be undefined and it's going to be broken. That's why mathematicians try to make a hole, because you can't divide by 0. That's undefined. Either you divide by 0, or you'll be able to cancel out a numerator and a denominator, and your x of the whole is going to be the opposite of the values. So if these were x negative 3s, these would be x equals positive 3. So holes are a way to help mathematicians and everyone know that there's something broken in these rational functions. So let's take a look at the problem. So the 4 things that we're going to look at are right here. Hole, y-intercept, y-intercept, x-intercept, vertical asymptote, and we're taking a look at this problem right here. So right here, it looks like there's a problem. Y equals parentheses x plus 2 parentheses x plus 3 divided by parentheses x plus 3 divided by parentheses x plus 4, which is a factored form equation. So let's try to go down the list and see what happens. And did you know that in order to kind of understand what the function's going to look like on the graph, it's usually a good idea to go in this order, but you don't have to. So let's take a look at that hole. So I have the thing copied down here. So holes happen when you cancel out or divide by 0. What can we do? Well, we have an x plus 3 here and an x plus 3 right there. What we're going to do is cancel them out. When we cancel them out, they won't appear anymore. Now we have to write some kind of new equation because we kind of did some damage to destroy the undefined properties. So we have a y, an x plus 2, and an x plus 4 as special fragments. We can rewrite the equation to say y equals parentheses x plus 2 and also x plus 4. We have an x plus 3 that we eliminated and got rid of. So the opposite of x plus 3 is x equals negative 3. Therefore, we would have to put that negative 3 in for x to solve for the y. Negative 3 plus 2, divide that by negative 3 minus, actually, plus by 4. So, we have negative 3 plus 2 is going to be negative 1. And negative 3 plus 4 is going to be positive 1. So a negative and a positive. So what's going to happen is we're going to transform that into y equals negative 1. So the first thing we did is the whited dot is going to appear at the point negative 3, comma, negative 1. If you were to graph it, that's where it would appear. So, the whole negative 3, comma, negative 1. Now, let's take a look at the y-intercept. Right here is kind of like a little map that I'm trying to make so we can see where to find where and what steps. So, the y-intercept is going to have the same equation. But hang on, what can we do to find the y-intercept? Hey, we have the equation right here, and the y-intercept has some kind of point that allows you to write it in like 0, comma, some kind of number as a coordinate. So what do? Yeah, you try to make y the answer by putting the zeros into here, 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 and here. So what we try to do is insert the zeros into the x. 0, 0, 0, 0. So in reality, the equation instead shall be 0 plus 2 is 2, multiplied by 0 plus 3 is 3, multiplied by 0 plus 3 is 3, multiplied by 0 plus 4 is 4, multiplied. But, didn't we forget about something? Yeah, we forgot that whenever we find the whole, it's going to be canceled out. So, this equation isn't going to really help us, but what it's really going to look like is y equals x plus to divide that by x plus 4 because we got rid of the 3's. That's why it's a good idea to start with the whole first. So 0, 0. So we have y equals 2 over 4. That is going to be our y-intercept. 0, comma, 2 over 4. Okay, and that is going to be by placing the zeros everywhere. Now let's take a look at the x-intercept. The x-intercept is also very easy, just like the y-intercept, but we try to keep the equation without the holes. Here's what happens. We write y equals x plus 2, then divide that by x plus 4, because we got rid of these red things because of the holes. So, what we have to do is equal it to 0. What we're going to do is do the top. So, x plus 2 equals 0. Sounds simple, right? Minus 2, minus 2, and x equals negative 2. On a coordinate, it would show negative 2, comma 0 on a graphing calculator. So, the x-intercept is going to be negative 2, comma 0. And last but not least, the vertical asymptote. The vertical asymptote is the last step that we're going to do before the video ends. And what it is if you take a look at these pictures right here, these graphs, the vertical asymptote is the one going up and down because the line is trying to move and get close to this value. And it's trying to get to that value as well. But it will never ever actually touch. Sometimes we might get more than one vertical asymptote. Maybe you should have 2, 3, 4, or more. So, let's see what we can do. We rewrite the equation y equals x plus 2 divided by x plus 4. What we have to do is, instead of doing the top, because that was the x-intercept, we do the bottom. So, x plus 4 equals 0. Sounds simple. Minus 4, and x is equal to negative 4. So, this is not a coordinate, because what's going to happen is it's going to be a dashed line from the top to the bottom. That's why you see dashed lines on these graphs right here. So, vertical asymptote is going to be x equals negative 4. And we're going to equal that to 0. So right here is kind of the color code, and here's the color map of what the math is going to do and where you should do your mathematics according to where they belong. So yeah, that is how we graph. Well, we're not graphing because that's going to be in another video. That's how we understand graphing rational functions part 1. Thank you for watching Top Opinion Line's Math Industry. Like and subscribe.